Hi guys, in this video we will see how we can blur detected object using YOLO V8 and count the number of objects in each frame. So here in this video we will be focusing on counting the total number of objects in each frame. As you can see over here, we are just counting the total number of objects in each frame. Like in this frame, the total number of cars we have, the number of trucks we have. So currently we are focusing on blurring the detected objects and counting the number of objects in each frame. Along with this, we are also focusing on object tracking and ID and trails. So in this video tutorial, so we will be focusing on object detection with tracking, ID plus trails, along with blurring the detected objects, as well as counting the total number of objects in each frame. So let's move towards the implementation part. So this is the GitHub repo of YOLO V8 with deep sort object tracking. So I have made a video tutorial regarding object tracking previously. If you haven't watched it, go to my YouTube channel and check the playlist over here. I will add the link in the description section as well. So you just need to open this GitHub repo. I will add this link in the description section as well. You can check out this link from there as well. And you just need to click on Google Colab file and just click open in new tab. So So for blurring the detected object, I will be using the OpenCV function cv2.blur. It's only the few lines of code. So first of all, we will be focusing on implementing object detection plus tracking, ID plus trails plus blurring the detected object. So first of all, we need to select the runtime as GPU, change runtime as GPU, and then need to connect on connect. Okay, so it's very simple and we will discuss it step by step. Don't worry. So meanwhile it's connecting, so just wait for a few seconds more and just now run the script. Okay, run anyway. So here I'm just cloning this GitHub repo. So this GitHub repo is being cloned over here and just setting the current directory. Basically currently it's set to content. So just setting the current directory as this repository and now installing all the dependencies, which include installing all the required libraries required to run this script. So we will not face any library issue because all the libraries will be installed when we run this cell. So using YOLO V8, we can perform segmentation, detection, and classification. But currently in this folk video, we will be focusing on object detection and tracking and blurring and counting the number of objects in each frame. So we need to move towards the required directory because we don't need to perform segmentation or classification. So our required directory will be this detect. So just copying this path, and if you just paste it over here, then we will be redirected over to this directory. So as we are implementing object tracking using deep sort, so we need to download the deep sort files as well and need to unzip them as well. So here I am just downloading the deep sort files. Because we are performing object tracking using deep sort, you can also choose sort, bytrack, non-fair, and other multiple algorithms are exist. But as far as I have tested and tried, deep sort performs best. And it also cover up all the issues which we faced in sort algorithm. So I have downloaded the deep sort files, but you can see over here, these are in the zip format. I need to unzip them. So I'm just unzipping these files over here. So the files are unzipped. Now you can see that this is the deep sort folder we have over here. So now we need to download a sample video for testing from Google Drive. So let's download it. Now let's run this script. Currently, this script will only perform detection and tracking. It will not blur the detected object. So let's run this script first and then made some amendments in the code and implement the object blurring as well. So it might take few more minutes. So let's wait. Mhm. Please bear with me, so it might take few minutes. So let's stop the script and just stop this video and let's wait until it finishes. So now you can see that the cell has run completely, and so let's see the results as well. Okay, so just move towards this cell. So just checking the results or print displaying the demo output video. Let's see what it gives us. Might take few more seconds. So let's wait and see. So here we have the output demo video. You can see here. Let me download it. So it look a bit pretty more cool. So just saying it. Let's check it out. So now you can see that we have implemented of detection and tracking as well, ID plus trails, but we have not implemented the blur. We have not blurred the detected object. So let's do it as well. So for this, just open the predict.py. So before we need go to implement blurring, so first of all, what we need to do? So implement blur the detected object. We need to know the coordinates of the bounding box, which is around the detected object. Like let me explain a more better way. For example, go to the pictures and screenshots. Which is the more appropriate? Let me open it. Okay, so just click over here. Okay, might just able to write something. Okay, just close this and open this in Paint. Open with Paint. For example, okay, so for example, we need to blur the object. Okay, so we need to blur the object inside this bounding box. So for example, we need to blur this call car, we need to blur this object inside this bounding box. So first of all, we need to know the coordinates of this bounding box. Okay, so we need to have the coordinates of this bounding box. So we need to know the top left vertex, this is the top left vertex. Writing is very poor, I know this. This is the top right vertex, basically top left vertex, and this is the bottom right vertex. So this is the basically the bottom right vertex. Okay, so we need to know these 2 points, the top left vertex and the bottom right vertex. So if we have this point, so we can know where we have the bounding box. So if we know these points, then we can blur the object inside the bounding box. So let's open the predict.py and explore this. So here we have the predict.py. So if we go below over here and just check this out. For example, let's over here, this basically xy. This contains the coordinates of the bounding box. So basically, let me open Notepad. This x and y contains these values, 0, which represents x1, and xy1, which represents uh, y1. Similarly, if we continue adding this 0, 2, and this 3, and let's make it x2, y2. So basically, here we get the coordinates of the bounding box. For example, xy, this can be simplified like this. Okay, so what is x1, y1? Let me explain this. So, so for example, just let me clean. Okay, sorry, let me open some another image. Okay, okay, open with paint. So if we have this, okay, so basically again it's the same issues here. This okay, so basically this represents x1, y1, and this point represents, which is the bottom right vertex. This is the bottom right vertex. This represents x2, y2. So this is x1, y1, and this is x2, y2. So now here we are getting these 2 points. So now we have the coordinates of the bounding box over here. Okay, so now here we have the coordinates of the bounding box. So now we need, as we have the coordinates of the bounding box, now we need to blur the object inside the bounding box. To blur the object inside the bounding box, we first need to crop the image, and it only contains the area where we have the bounding box. So first of all, we have the coordinates of the bounding box. So now we need to crop the image, and it will only contain the area where we have the bounding boxes on the image. So now let's do it. Right, crop, create a function crop dash object and write im0. Im0 basically is the name of my image, or you can say that uh, video is being passed frame by frame. So this is the current frame. You can say that im0 is then the current frame, and you can just write int xy 1 column int xy column 3 int xy column 1 int xy 2. So what this means basically, now we are just cropping the image, and just you can say, and it only contains the area basically where we have the bounding box. So in start, we can just writing it like this. Basically, we are just, you can simply say that we are just doing y1, y2 with x1 and x2. Okay. So this is what we are doing currently. Now let's move ahead as well. So let's a bit make it easy for you. Okay, so here we should have y1, y3, and x1, 0, 2. Okay, so now we are creating, now we'll blur the crop image. Basically, now we have the area of the bounding box. So now we are just going to basically blur this area. So using cv2 dot blur, I will write crop dash object. So now we only have the area of the bounding boxes uh, of the detected object. Now we are just, this is basically the blur ratio. The blur, as we, if we keep the value of blur ratio high, so it will completely blur it. So you can set it as per your requirements. I'm just setting it 20. It is from 0 to 100. So this is the blur ratio simply. So now we are just setting. So now just copy this code from here and just write blur and just save it. And now just check it either it works or is there an issue, then we'll correct this out. So now let's run the script again. Okay, sorry, this mistake, a mistake. It's okay, just correcting it. Now let's run this part of the script as well. Mm, just waiting for it. It's okay, let's run this script. It might take few more minutes, so let's wait and until it completes. Okay, CV2.learn. What is the issue? Let me see over here. Let me open predict.py. What it says. Let's see. Check. So I have made a short mistake over here. Just correct it out and just save this. I think I'll just save it out and just again this and just check it out. And just now we'll just again rerun it and check it if there is an issue further, so we can correct it as well. It might take few more minutes. Let's see. So just running the script. Okay, now it's running. So now let's wait. Now let's just pause this video and let's see. Get back when it's completely run. So now the script has successfully run. Let's check the demo output video. Let's write 23 test one. It might take few minutes. So let's wait and check the output video demo. While if you want to just download it from here, it might be get you might get things done a bit early. So let's see. So here we have the results for the object blurring. Let's download this video and just stop it. So it's downloaded. Let's open it. So cool. We are able to blur the detected objects. You can see that the results are quite good. So we are very well done. So we have done the object blurring. And we have also implemented object detection, tracking with ID and trails, and object blurring is also implemented. Now let's move towards counting the number of objects in each frame, the total number of objects, like it can be number of cars are 10, number of trucks are 14, or number of bikes are 15. So let's count the total number of objects in each frame and let's move towards this code part. Okay. For counting the objects in the current frame, I will not be writing the complete code. I have written the code. So I will be just uploading over here and then I will explain you because it's a bit lengthy code and this might take more time and the video will get pretty long. So just skipping this for you. So just upload the updated code. Let's go to YOLO and my own data. Where we have just learning just jumped out this file. So this file already contains the object blurring detected object blurring code which we have added previously. Let me show you as well. So this is the add object blurring code we have already added over here, which I have already explained to you previously. So now let's discuss the code for the counting the total number of objects in each frame. So here is the code to count the number of objects in each frame. So for example, here we are getting the sum of detections per class. And here we are creating a dictionary by the name founded classes. Founded classes is a dictionary basically which contains the object name and its count, the number of time it has appeared in the current frame. So founded class is a dictionary which contains the object name and its count, the number of time basically it has appeared in the current frame. So here we are just calling a function by the name count. in which we are calling passing the founded classes, which contains the object name and its count the number of times it has appeared in the front frame. So basically, founded classes is a dictionary which has a key, which is the object name, and value is the number of which is value is the basically the count, the number of times the object has appeared in the current frame. Okay, so let's see the count function, what it does. So in the count function, we are just extracting the keys and values from the dictionary. And you can see here, this is the key value and this is the like the object name. This contains the object name and this is the count value, like the car has appeared 5 times or bus has appeared 3 times in the current frame. And here we are just creating a rectangle and just putting the text of the number of times the object has appeared in the current frame, like the cars 13 times or 14 times. What is basically this is basically here I'm just making the adjustment, like the car will appear on the top, the number of times the car has appeared in the current frame will appear on the top, then below we have the bus, and then below we have the truck, and below we have the traffic light. So these are all the UI adjustments I am making over here. So now let's just run this out. So just running this. Okay, so let me fix this up and just run this. So just give me a minute. Okay, now let's run this and check the results, how our results look like. Let's see. So it might take 1 to 2 minutes and let's see. I will be back at its complete uh, running process. So the cell has completely run. So let's move ahead and just check it out over here. Okay, just run this out. And let's see what results we get. I'm just running this cell and just see what results we get. It might take few minutes, so let's wait for it to run completely. Okay. So it has successfully compiled. So let's check the demo output video. So here we have the demo output video. So you can see that we are able to detect the object. Plus, we can also implementing the tracking. This is that I tracking trails, and this is a unique ID of each object. So we are able to implement object detection, tracking, plus we are able to blur the detected object. And this is the count, like you can see that count of total number of objects in each frame. So the count will change as it moves towards the next frame. Here the count will again change. Here we have only cars, like you can see that no other object we have. And so you can see it over here. So here we have around, you can see that we have 3 buses, one, two, three. So it shows 3 buses. So it shows the total count of each of the object in each frame. Like you can see that we have one truck. So it shows one truck we have as well. So this is very good and results are very good. You can see that we are able to implement object detection, tracking with ID and trails. Plus we are also able to implement object blurring and total count of objects in each frame. So I hope you have learned a lot from this video. So do share it with your fellows as well. And I will be sharing complete GitHub repository for this project as well in the description section as well. So you can check it out and explore it further. Thanks for watching. Bye bye.